Hello everyone, today we will be talking about this resistor over here. I bought this resistor to use as a shunt to measure current with this current clamp multimeter. Um, you might already know why I want to do this, but it's just because this current clamp multimeter can only measure AC current with its clamp, and in order to measure DC current I will need a shunt resistor. I would like it to connect directly to the multimeter's banana jacks. I think that's what it's called. Uh, so I've got plenty of goodies. So here are the ends of two old multimeter leads, and here is that old broken multimeter that is the reason that I bought this newer one. And in fact, if I was to open this and put in a battery. This is a brand new 9-volt battery. And then turn it on, it just does weird stuff. Like, yeah, even though some of the stuff does appear to work, it really does not. This multimeter is dead. So, what I'm gonna do is take this apart first by ripping this off, and then using my multi-tool screwdriver to remove all of the screws. Well, this thing has just 2 screws on the bottom, so I'm not going to bother pausing the video. And let's see if we can crack it open. There we go. So, on the inside, we have a bunch of stuff, really, but all I'm interested in is 2 of these banana connectors. So, well, let's just pop out some of these fuses. They might be useful later. Well, my main focus is these female banana jacks. And, in fact, let's get the rest of these screws off. I'm not going to bother putting them in a tray because I do not intend on putting this thing back together, unlike most of the things that I take apart. So, as I continue to unscrew, I am noticing that these banana jacks, they're just it's just a piece of metal that has been formed into a loop of sorts. And well, I'm not gonna bother. Okay, so here it is. Uh, these are the things that I want to remove. These are the female banana connectors that mate with the male banana plugs. I'm not completely sure why they call it that, but humans give things weird names sometimes. Anyway, my soldering iron should be up to temperature by now, and I'm going to use an alligator clip to grab a hold of one of these, and then turn on the fume extractor, heat it up, then there's one. Is it hot yet? There we go. So here are my 2 fresh banana connectors, and they mate with the banana jacks just fine. So now I can get rid of this, and I can solder these to this resistor. Well, not yet, because I'm gonna have to chop up these wires first. This looks like a relatively lower gauge wire than what I'm used to for strand cores, so I'm going to try to actually strip it. And it looks like it worked. So let's do the same thing with the other one. Cut. and strip. There we go. Now I can take my 1 ohm resistor and pass the wires through. It doesn't matter which way the wires go, so because resistors are non-polarized components. Where's some solder? Here is some really cheap and crappy soldering wire that I used in my last video about coloring titanium. Actually, nah, that's not good. It has to be further in. For applications like this solder is fine, but uh, it doesn't exactly smell great. Probably not that good for me to breathe, and it's very low quality. I'm not. It's terrible solder. But anyway, let's just get this thing in there. Well, this is gonna take some time. Let's add a bit more of this extremely bad quality solder onto there. And then I can melt these two together. Is it working? Is it working? Not that well. Well, anyway, let's just try to solder on the other one while I'm at it. Yeah, this solder also has a tendency to just bunch up and become mushy when it is almost hot enough to melt, but not quite there yet. Where are my tweezers? Here they are. So I will just use it to poke a hole through this through the hole here. And where's the smoke coming from? Whatever. Probably not a big a deal. Let's see if I can poke it through there. Well, maybe I'll have to do it like this. And heat the solder up. Well, calling it solder is a bit of a stretch, since it's so bad quality. Well, the hole's open. Even if it's not, open very wide, it's still open. Let's see if I can remove some of the excess solder from this wire here, and then put it through there. Well, it's still not open enough. Maybe it's a better idea to pass it in from the other side since most of the solder is right there. So now let's flow it around the open wire. Oh, there goes most of the solder. So let's just do this. Oh my goodness, this is genuinely terrible solder. Okay, well, let's just heat it up for a while and then hope that it all bonds nicely. Okay, there we go. Good enough. So now, that's only half the story though. So next, I'll have to take these banana connector things and well, chop off some of the rest of some of the excess wire. Now I can take these banana connectors and then I'm just gonna I'm just gonna put it on like that. I'm not gonna bother putting some extra wires on it. Let's see if I can find some better quality soldering wire. That's better. So let's melt. Actually, let me think. If I do it like this, yeah, that would be pretty good. Well, whatever. Let's just see if I can do this at all. Maybe I can coil it around so that it stays tight like that. And now I can flow that with some solder. Well, I guess that kind of does it. Maybe my soldering iron isn't hot enough. Yeah, it's not even a 300C. Oh my goodness, maybe that's why the solder was so bad, because it wasn't melting properly. Well, that should be good enough for one. Now I'm going to put this other one right here. Well, maybe I should straighten it out first, and then coil it up. Well, calling that coiling is a bit of a stretch, but now that my soldering iron should be a bit hotter. Oh, this is terrible. I really need some sort of clamp thing to hold this in place, but whatever. And now that this is hot, I guess I can try to do this again. The solder will not melt. Whatever. Oh, that's hot. Probably why it's not melting. It's got so much thermal mass. Okay, this is kind of tough. Let's just see if I can do this. Oh, this is terrible. Just terrible. Oh, I think it made it. Probably very hot though. Well, not as hot as I expected. So, oh, there, it broke. Oh, well, maybe that's a good thing that it broke, because now I can get it into a more secure spot. Let's reflow this solder. And wait for it to heat up. And put a bit more solder on there. Oh my goodness, this is not melting. Well, it reflowed technically. Yeah, maybe I should have put these on wires. Okay, that's one wire made out of the remains of the wires that I had from the multimeter, from the old multimeter probes. They were broken anyway. Let's see if I can get this to work. Maybe it just needs a bit more solder. Well, it is technically soldered, but I just want to make sure. Okay, that's pretty secure. Now let's take the other end and hook it up to this side. Well, after breaking off the original barrel connector. Even though there's still a thermal mass of the resistor's contact, there is still there the thermal mass of the big bulky banana plug is now missing, so it should be better now. Yeah, the resistor is getting warm from all this soldering. I thought this would be simple. Ah, whatever. It's working, kind of. Does this hold? Yeah, it does hold. Okay, now let's do the same thing to the other one. And just like that, my little shunt thing is complete. So, let's see if this works. I will plug in the resistor to the COM and that pin, and I can just use the original probes with these banana connectors. Why they call them banana connectors, I have zero clue, but they do for some reason. So that's both of them connected. Now the probes are right here. Well, oh my goodness, my desk is way too messy. There we go. So there are the probes. I need some sort of current source. Well, I don't know what I can use for now. Well, let's just use dollar store 9-volt battery. Let's prop this up. Set it to the correct setting. And let's see if it does anything if I probe across the battery while the shunt is connected. It said 0.8. It said 0.85, almost 1 volt across this resistor. That's because that equated to roughly 850 milliamps, even though that it said 85 on the screen. The way it works is that if you have a 1 ohm resistor, then the voltage across it is the same as current flowing through it in amps. So, because I was measuring it, okay, well, because the decimal point is right there, then 1 would be over, 1 amp would be over here, 100 milliamps would be over here, and 10 milliamps would be over here. This wouldn't exactly be a very precise current clamp meter, especially for small currents, but well, definitely does seem like it works, but in order to confirm, I have to test with a known current source. This little power supply should produce around 190 milliamps when it's short-circuited. I'm only going to do this for a very short period of time because it doesn't have a heatsink on it. I could attach a heatsink, but I'm too lazy to do so now. So, let's see if it can measure the current. It should say 0019. Perfect. So it looks like my little creation that is a shunt a shunt setup for a multimeter looks like it works.